Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of differential equations. And if I talk about the question that is given to us here from this topic, the question tells us let y equals y of x be the solution of the differential equation which is given to us as sec y dy over dx plus 2x sine y equals x cube cos y. Now the question is telling us that y at x equals to 1 is 0. Then the question is also asking us to figure out y at x equals to root 3 will be how much. And if I talk about the answer choices that we have been given here, the options are pi over 6, pi over 12, then we have pi over 3 and pi over 4. So we need to figure out which one of the answer choices is the correct answer for the question that is given to us here. Before starting off with this solution for this question, I'd first like to tell you that please do subscribe to my channel because it is free for you, but it also motivates me to put up better content and try to make the solutions as easy as possible so you understand them in a better way. Let's see the question now. So if I write the question's differential equation I have here is sec y dy by dx plus 2x sine y equals x cube cos y. Now, if I divide everything by cos y, what do I get here is sec y divided by cos y. So it basically becomes sec square y dy by dx plus 2x tan y equals x cube. So this and this gets cancelled and you're left with x cube. So we get this differential equation. Now here what I can do further is I can put tan y as let's say t. In that case, sec square y dy over dx will become dt over dx. So from here what do I get is dt over dx plus 2xt equals x cube. So I have my differential equation of this form, and once I have that in the form, I can just compare it with dy by dx plus by equals q, where instead of y, I have t here. So in that case, my p becomes 2x and my q becomes x cube. So once I have p and q with me, I can just find my integrating factor, which is e raised to integral p dx, which is e raised to integral. P in this case is 2x. So I get from here e raised to 2x square over 2. So this cancels and you get e raised to x square. Solution for this type of differential equations is y into if is integral of q into if into dx plus c. Now instead of y we have t everywhere, so let's put t everywhere. If is your integrating factor, which is e raised to x square, is equals to q, which is x cube, and if is again e raised to x square dx plus c. So let's try to evaluate the integral this. Now if I do that on the second page, it says integral of x cube e raised to x square dx. So we have in this case put, let's say, x square as z. So in that case, 2x dx is dz. X cube, I split it as x square into x. So x square as it is. So my integral becomes x square, I'm writing z. This becomes e raised to z, and this x and dx together becomes dz over 2. So I get dz over 2. Now once I have this, I can write this as half integral z e raised to z dz. So now once I have this, what I get is integral of u into v, which is u integral v minus big integral derivative of u integral of v, the whole thing again integrated. So if I use that according to my idea of Lie, I have algebraic first and exponential next. So algebraic should be u and exponential function should be v. So z is u, e raised to z is v. So if I use that idea half out as it is, z integral of e raised to z minus the big integral derivative of z, which is 1, and integral of e raised to z, which is again e raised to z. So here I get half z integral of e raised to z is e raised to z minus integral of 1 into e raised to z, which is integral of e raised to z, which is e raised to z. So we get from here half z minus 1 e raised to z. So that's your entire value of the integral that we have here. Now, once I have that with me, if I put it in the solution here, I'll resubstitute first z. So I get from here half z is x square minus 1 and e raised to x square. So here I get half x square minus 1 e raised to x square plus c. T, I resubstitute here, let's say. So I substituted y or tan y as t. So if I resubstitute, I can just write t as tan y. Now let's try to find the value for c. So before finding the value of c, it says at x equals 1, y is 0. So if I put that, x equals 1, y is 0. So that gives me tan 0, which is 0, half into this becomes 1 minus 1, which is 0 again, plus c. So you get c is 0. Once I see constant of differential equation is 0 here, I get my solution of the differential equation, which is this. So you get tan y e raised to x square equals x square minus 1 e raised to x square divided by 2. E raised to x square I cancel from both sides, so I get tan y equals x square minus 1 divided by 2. The question is asking me at x equals to root 3, what will be the value of y? So if I put it there, so tan y root 3 squared, so 3 minus 1, 2, 2 divided by 2, which is 1. So here I get y is tan inverse of 1, which is 45 degrees, and that's pi over 4. So I get the value of y, and that becomes pi over 4. That matches with answer choice D. So D becomes the correct answer for the question that is given to us here. I hope you have understood how to solve this type of questions, which deals with the ideas of using the concept of differential equations. I'll see you again tomorrow with some other question from some other topic, and we are going to continue our series of questions on JEE mains. So stay tuned for more videos to roll out. Also, if you're enjoying these videos that we are doing on everyday basis, please do like the videos as well, and do subscribe to my channel and share this channel with your friends also who are involved in the preparation of questions on JEE. So they can also take the benefit from these questions that we are solving. Thank you.